Hello everyone. For this video, we are going to discuss about rules on differentiation. But before that, let's talk about some notations when it comes to derivatives. Here we have f prime of x, the derivative of our function, but it can also be d over dx or the derivative with respect to x of our function. Next we have our output y, our y prime or our dy over dx, or the derivative of y with respect to x. All of these are just the same. We're just concerned about getting the derivative of our function. Now that we are familiar with this notation, now let's talk about the basic rules when it comes to differentiation.
The first rule is the constant rule. Constant rule means that if f of x is equal to c, where c is a constant, then the derivative of a constant is equal to 0. So we have here an example. First is we have f of x is equal to 10. As I have said earlier, the derivative of a constant is equal to 0. Thus, the derivative of f of x is equal to 0. Next example is g of x is equal to 5 pi. So same as the first example, the derivative is 0. Last is f of x is equal to square root of 2. The answer for this example is, that's right, 0.
Next is we have the power rule. This rule states that if f of x is equals to x raised to n, then the f prime of x is equal to nx raised to n minus 1. Take a look at this example. F of x is equals to x raised to 4. We have here 4 as the exponent, so we're going to put it to the front. Copy the exponent 4, then x. Next example is g of x is equal to 1 over x raised to 3. As we can see here, our example is in fraction form. So we can convert it into whole number by getting its reciprocal. Our numerator is 1, so we just need to copy the denominator, then change the sign of the exponent to negative. Now that we already have its reciprocal, we will apply the same thing as we do to the first example. We will bring the negative 3 to the front, then multiply it by 2. So negative 3 times 2 is negative 6. Copy x, then subtract the exponent by negative 1. We will bring the negative 3 to the front. Then copy x, then subtract the exponent by a negative 1. So, negative 3 minus negative 1, that's right, negative 4. So our final answer is negative 3x raised to negative 4 or negative 3 over x raised to 4. Last example is h of x is equal to the square root of x raised to 4. First thing that we will do is to get the square root of x raised to 4, which is x raised to 2. We can now get the derivative of it. Same as we do to the previous examples, we will bring the exponent 2 to the front. There is no other constant here aside from the invisible one, so we just copy 2, then copy x, then subtract 2 by 1. Our final answer will be 2x.
Next rule is the constant multiple rule, where we apply the constant rule in the power rule. This states that if f of x is equal to k multiplied by h of x, where k is a constant, then the f prime is equal to k multiplied by h prime. Our first example is f of x is equal to 2x raised to 3/4 minus 6. Here we can apply the power and constant rule. So here we can use the power rule. Let's bring the exponent 3/4 to the front, then multiply it into the constant 2, which gives us 3 over 2. Then subtract the exponent to 1. So copy 3 over 2, then x, then 3/4 minus 1 is negative 1/4. That leads to our final answer, which is 3 over 2x raised to negative 1/4 or 1 over 3 over 2x raised to positive 1/4. Next is h of x is equal to negative 6x raised to 5. First is bring forward the exponent pi to the front, then multiply it by negative 6. 5 times negative 6 is negative 30. Copy x, then subtract the exponent by 5. This leads to the answer of negative 30x raised to 4.
Next rule is the derivative of a sum or a difference. This states that if f of x is equal to g of x plus or minus h of x, then f prime is equal to g prime plus or minus h prime. First example is f of x is equal to 5x squared minus 2. First, if we need to identify where is the g of x and the h of x, after that, we need to get the derivatives of both functions. Let's first get the derivative of 5x squared. By applying power rule, bring the exponent 2 to the front and multiply it by 5. 5 times 2 is 10. Then copy x, then subtract the exponent by 1. So the derivative of g of x is 10x. Next is the derivative of h of x. Same as before, here in x, there is an imaginary exponent 1, so we will move it to the front then multiply it negative 2. 1 times negative 2 is negative 2. Then subtract the exponent by 1. So 1 minus 1 is equal to 0. Thus, we will cancel the variable x. We have the value of g prime and h prime, so we just need to combine them. Our final answer will be 10x minus 2. Next example is f of x is equal to 3x minus 4 times, thus x square root of x plus 3. For this problem, since it's a trinomial, let's get the derivative of each. Our g of x will be 3x squared. H of x is negative 4 times the square root of x. Then our p of x will be positive 3. First is let's get the derivative of g of x. G of x is equal to 3x squared, so bring 2 to the front then multiply it by 3. The derivative of g will be 6x. Next is the derivative of h of x equals to negative 4 times square root of x. We know that the derivative of square root of x is 1 over 2 squared x, so we just need to multiply it by negative 4. So negative 4 multiplied by 1 over 2 square root of x is negative 4 over 2 square root of x. This is not our final answer since we can simplify it by cancelling 4 and 2. So 4 became 2, then 2 became 1. So the final answer is negative 2 over square root of x. Last is the derivative of p of x. As we can see here, we can apply here the constant rule. So its derivative is automatically 0. Now let's combine all the answers. So the value of f prime is 6x minus 2 over square root of x.
Next rule is the product rule. This rule might be confusing, but it's just simple since you just need to apply the previous rule that had been discussed. This rule means that the derivative of f of x times g of x is equals to f of x times the derivative of g of x plus g of x times the derivative of f of x. Take a look at this example. Our given is y is equals to the 2x to the 4th minus 8 times x to the 4th minus 6. Let's first identify the value of f of x and g of x. So, the f of x will be 2x to the 4th minus 8, and the value of g of x will be x to the 4th minus 6x. Since we already know f of x and g of x, we can now get the derivatives of them. To get the derivatives of f of x, we will use the constant multiple rule and the constant rule. Bring the exponent 4 to the front and multiply it by 2. Then, 4 times 2 is 8. Then copy x, then subtract exponent by 1. Since negative 8 here, as you can see here, is automatically equal to 0 because, that's right, we apply the constant rule. Our final answer for this function is, that's right, 8x cubed. Now, let's get the derivative of g of x. In here, we just need to apply the power rule. So, bring the exponent 4 to the front, then here, the exponent here, yes, that's right, subtract it by 1. So, 4, copy x, then 4 minus 1 is 3. Then here, negative 6x, what are we going to do to this? Yes, so we just need to cancel the variable x, so our final answer is 4x cubed minus 6. Now, let's get back to this equation here. So, we just need to substitute the answer that we got to this equation, then simplify it. So, our new equation is y prime is equal to 2x to the fourth minus 8 times 4x cubed minus 6 plus x raised to 4 minus 6 times 8x cubed. So here, we just need to simplify it. So, as you can see here, using the FOIL method, so 2x raised to 4 times 4x cubed is equals to, yeah, that's right. So 8x raised to 7. So next one is 2x raised to 4 times negative 6 is negative 12 raised to 4. So next one is negative 8 times 4x cubed is negative 32 cubed. Then negative 8 times negative 6 is positive 48. Next one is x raised to 4 times 8x cubed is 8x raised to 7. And negative 6x times 8x cubed is equal to negative 48x raised to 4. Now let's combine the like terms. So we have here 8x raised to 7 plus 8x raised to 7 is, that's right, 16 raised to 7. So negative 12x raised to 4 plus negative 48x raised to 4 is equals to negative 16x raised to 4. Since, look at here, so since negative 32x cubed and positive 48 doesn't have any like terms, we just copy them. So that leads to our final answer, which is 16x raised to 7 minus 60x raised to 4 minus 32x cubed plus 48.
Now the final rule is the quotient rule. This rule can be confusing at first, but it is really simple and easy to learn. You just need to carefully listen to understand this rule. Now, let's begin. This rule means that the derivative of integral of f of x is divided by d of x is equal to g of x times the derivative of f of x minus f of x times the derivative of g of x, then divided by g of x squared. Now let's take a look at this example. Our example is h of x is equals to 6x plus 10 over x squared plus 9. Let's first identify the value of f of x and g of x. So, the f of x will be 6x plus 10, and the g of x will be x squared plus 9. Since we already know the value of f of x and g of x, we can now get the derivatives of them.
The derivatives of f of x is 6, since we can apply here the power rule and the constant rule. And the derivatives of g of x is 2x, by applying the power rule and the constant rule.
Now, let us substitute all of our given derivatives. Substitute a g of x with x squared plus 9 and multiply it with the derivatives of g of x, which is 6, minus the f of x, which is 6x plus 10 times the derivative of g of x, which is 2x. Now divided by the g of x squared, which is x squared plus 9 squared. The next step is to do the FOIL method to multiply the given. X squared multiplied by 6 is 6x squared. 9 times 6 is 54, minus negative 6x times 2x is negative 12x squared. And finally, 10 times 2 is 20x, all over x squared plus 9 squared. Now finally, combine all the like terms with the final answer of negative 6x plus 20x plus 54, all over x squared plus 9 squared. And that's how you use the rule of quotient. Now, we all know about the different rules of derivatives. We hope you learned something new today and hopefully understand the different rules under the derivatives. They say practice makes perfect. So practice your derivative skills to be able to master it in the future. Thanks for watching and goodbye.